Alright, hell yeah. So today we're going to go over inequalities, and inequalities that also involve absolute values. And I should be looking this up, but anytime that you have an absolute value, you have a possibility of more solutions. And so inside this absolute value, let's say it's just a linear equation. Well, now you have the possibility of two solutions. And we can even just write this on a graph where if this was a linear line, but you know what I mean, we had this equation, but we had the absolute value of this equation, it can't be negative, and so we would see the reflection. So now this would be the graph of a line. And then let's say we want, so this is one of the equations, and we're going to say, hey, let's say that's equal to a constant. Well, maybe this is your constant. And then so that's what we're going to see even for this. So this is the first one up. We'll talk about it in a second. Hell yeah. And you know, let's just kind of drop this term, but we're going to have, you're basically going to have the equation of x. So like this is y is equal to x on this side. And then right here is $1,000. Okay, hell yeah. And then if I went into the negative money, you know what I mean, that is going to be what we're going to call positive money. And I'm going to show you an example, and I'll just get to it right now. Like, hey, I could pay the dentist $1,000 in real cash. I'm going to say that's positive money. Or I could do credit, and I'm going to say that's negative money. Okay, I could give them $1,000. They're getting paid. You know what I mean? But you could consider negative $1,000 as negative money. And so here is the equation that does that. So now this is going to be y equals the absolute value of x. And we're going to say y is equal to, you know what I mean? We have at least an equal sign here. So I can say, hey, y is equal to 1,000. And because... and then, so these two things are equal. So I have the absolute value of x is equal to $1,000. And so x can be either 1,000 or negative $1,000. Both of those satisfy. And then if you're going to pay the dentist, you know what I mean, anytime you have like a bill, you have to pay equal to that, or you could pay more. You know what I mean, you could tip. I don't know if you're going to tip a dentist. Probably. Well, maybe. You know what I mean? If you want to, my dentist is my friend, so that's pretty sweet. I don't know if I'm going to be tipping, but I'll give him tips on the river. Hell yeah. So anyway, all right. So we have, so you have this $1,000, and now what does this inequality, you know what I mean? It says that this side has to be greater than this constant. So this line is going to be our constant of $1,000. And this side has to be greater. So this is the equation that represents that side. And so if I hit these values, hell yeah, like we're in. And so let's say this value right here is going to be $1,100. So I'm going to have positive 1,100 and then negative. This is going to be negative 1,100 and then positive 1,100 over here. So both of those are going to be solutions that satisfy. I can give the dentist 1,100, you know what I mean? It pays the 1,000 plus a tip, or I can give the dentist that negative 1,100, which I'm going to say is credit. So this is cash, and that is credit. Hell yeah. So this is kind of just one example of just like, well, why would a larger negative number, and so see how I said that, a larger negative number. So if I'm going to say negative money is credit, you know what I mean? Like using a credit card or something, or getting a loan. The person I'm going to give that negative money to definitely wants more of that negative money. You know, if I gave the dentist negative $2,000 because I took $2,000 out of the credit, the dentist is going to get $2,000. You know what I mean? But you can consider this. I just thought that was one way to consider this negative money. All right, hell yeah. And so now for our next example is going to be a bid on the house. And so again, we're going to have an equation of x. And because we have an absolute value, if I throw any number into this absolute value, you know, if I throw, and then we're bidding on a house. So if I throw in negative $400,000. This absolute value is going to turn that into a positive number. So there's no way on the graph of this to be below this x-axis. And so what we see is a reflection. And so here is our graph. Again, this is y is equal to x. We're going to come back to this one because I made this one specifically because you're going to get two different values. Now, did I do this right or wrong? I don't think I did this right. I'll have to come back to this one and see. Because what I wanted to do here is if you actually pay cash, you get a discount. But if you pay credit, then you actually pay more. And so so I wanted to show that. I think I need a negative right here. That's what I need, right? I'm trying to think of what I need. All right, we're gonna move on to the next example, but be thinking about this one because I think I need to do this x and then outside the absolute value plus 0.05x. So this would be, you know what I mean? I'm either adding 5% to the bill or I'm going to be subtracting 5% from the bill. Let's say I did have $1,000 right here in positive cash. The equation would need to be subtract. If I pay $1,000 in cash, I get to reduce that number by 5%, and that's what I get to pay the dentist. You know what I mean? So the dentist, 5% of $1,000, what is that? $50, and so I pay the dentist $9,950. Hopefully, I said that right. I have no idea. 1,000 times 0.05. Sometimes it's hard to think on the fly, and I kind of mess up that equation. But yeah, so now that we have that, let's stick with this. So I'm gonna pay the dentist x minus 0.05x, and that has to be greater than. And so this is where. This is where this part can go to the other side. If I do have this, and then I say this has to be $1,000. I wanted like the 1,000. So this is what happens at the dentist. Let's say your bill is $1,000, and then they're just like, well, if you pay cash, it's going to be like $9,900. So what I wanted to do for this problem was pick a midpoint. That means that if I pay it with a credit card, I'm paying this. If I pay cash, I'm paying this. So it seems like we could say the actual price is right in the middle. You know what I mean? So that's kind of what I wanted to explore with this problem. So, and I think this does it. And this is one issue that comes up also with dealing with inequalities and absolute value signs, is that we want to, you know what I mean, at some point get the absolute value by itself. So we're going to do this, and then we're going to get this to the other side. Now this is where I had to look these up. The rules for this inequality sign, greater than or less than, you know, we could do a less than sign, we could do a greater than or less than or equal. Any of these things, if I'm going to add or subtract, you know, the same thing on both sides of the equation to move things around, this sign doesn't change. If I multiply or divide by positive numbers, this sign doesn't change. The only time this sign will change, and I think, you know, then it's like, well, what if I square both sides of the equation? Probably doesn't change. What if I take the square root of both sides of the equation? Probably doesn't change. So the only time it will change is if I multiply both sides of this equation by a negative number. Doesn't have to be just -1. It could be -5, you know what I mean, on both sides. So if I do that, multiply both sides by that negative number, that has this sign has to flip. All right, and that's what we're going to kind of explore, you know, with kind of the other examples that I did. So let's rewrite this. So I have, hell yeah. So this is what we're going to have at the dentist office. I'm going to get this to the other side because I'm adding to the other side. It doesn't change this sign at all. So it's still, this side is greater than, and then I'm going to have 1,000, I'm going to have plus 0.05x. Now, and this is where I just went to like the organic chemistry tutor. They said, you know, one way to look at this problem is to break it up into, and let's see if I want to go down this road. Yeah, we will just for formality, because I do like this approach. If, like this side, it looks like a positive number. And that's the other thing, because there's hiccups with this. If this side was a negative number, you know, and this side was an absolute value, and this side is a negative number that's not just zero, it's a negative number, then there's no way that these two things can make sense. You know what I mean? Like this side can never be bigger. No, never mind. If this was negative, this side would always be bigger. But if, how does this work? Yeah, if this side was positive, then there's a chance that this side might be smaller. Yeah. All right, so let's, you know, I was a little confusing there, but one thing you can do is just throw in a value of 0. If I throw in 0 here, is 0 greater than 1,000? No. So at least we have one that doesn't work. And then we can say is like, well, is there one that will work? Let's say I put 1,000 right here. Is 1,000 greater than 1,000 plus some more? No. You know what I mean? So no. Let's say I put a negative 1,000. So this is negative 1,000 with the absolute value. That becomes positive 1,000. Is positive 1,000 greater than 1,000, you know, now minus something? Yes. Okay, so we at least have one solution that will work. All right, but I messed up my equation anyway, because if I do the credit, if I throw a negative $1,000, you know what I mean, then this side will be bigger. Oh yeah, let's run with this. Okay, because what I watched a video on this, and so what you can, let's see if I made a mistake. I don't know if I did. It's hard to tell. But if you get down to the absolute value here, you know, I can say that x is greater than this side. That's one that I can do that will work. Or I could say that x is the negative of this side. So I could just do like -1 times this side. So whatever this side was, I'm going to take the negative value of it. And because I multiplied this side by a negative, this has to switch. And then let's talk about that. I'm paying the dentist. So this side says that I have to pay the dentist in positive money. See, and that's why my equation is messed up, because we said if you paid cash, you were going to get a discount. The way I have it set up is if I pay cash. If this is a positive value, then it's going to be greater than 1,000. Well, no, that's not true. No, this works, because I can now subtract, I can get this to the other side, which is now 1x minus 0.05x. And so I'm just going to say that's 0.95x is greater than 1,000. And if I solve for x, x is greater than 1,000 divided by 0.95. And so let's do that. 1,000 divided by 0.95. No, so that didn't work. Yeah, so this equation probably should have a positive sign right there. But let's just go with it. Let's say so what we have here, you know what I mean, if we're following the numbers, is that if I pay cash, I'm actually having to pay more. They don't want me to pay cash or whatever. So that means that I can pay $1,052.63. That's what I need to pay. All right, hell yeah. So now let's solve this equation. So this is if I'm paying negative money. If I'm giving them credit, now let's see how much I have to pay them. So I'm going to have x is less than, I'm going to factor this through, negative 1,000 minus sorry, I need ice water, 0.05x. I'm going to add 0.05x on both sides. This is 1x plus 0.05x. So now I have 1.05x on that side and negative 1,000 here. If I'm going to solve for x, I'm going to, yeah, and at no point over here, like when I got this, you know, I'm still just dividing by a positive 0.95. So that's what I did on both sides. This equality sign doesn't change. All right, hell yeah. So now I have x is going to be negative $1,000 divided by 1.05. Dividing by a number bigger than 1 is going to kind of reduce this. If you divided by 2, that would half it. And so my x value, so I just have it messed up, but we have 1,000 divided by 1.05, and this would say I had, if I paid in credit, I would be getting a discount. And so that's what my bill would be. So let's do this one more time and switch this equation to a positive sign, and then we'll get, hey, if I pay cash, this will be less. If I pay credit, this will be a larger negative number. But that's why this x is, that's why we flip this equality sign. I'm sorry, inequality. Yeah, inequality sign. Because if I'm paying the dentist in what I call negative money, the dentist wants more of that negative money. Negative money to me just means a bigger bill on my credit card. And so the dentist wants a huge bill on my credit card so then they can get that juice. You know what I mean? So that's just kind of one example of showing you that, hey, negative money, you know, using, like, why would you have an example where the negative, you know, where you're just like, hey, I either have to pay $1,000 in positive money or negative $1,000, and or more. I would have to pay equal to that or more than that. So in this case, I would be equal or more than that. And then the word more negative money is not how we use this less than sign. So if I say something is more negative, I just mean that it's less than that. So I need this to be less than, you know, if I had negative $2,000, you know, that's what I'm paying my dentist, then that's less than. Negative 2,000 is less than or equal to negative 1,000. And my bill that I'm paying has to be less than or equal to negative $1,000. I either have to pay negative $1,000, which is what we're saying is credit, or I have to pay more negative, which is just less than that. And so that's where I came up with, you know, I think this is pretty good to come up with an example where less than is a greater negative number and implies your credit card is going to get billed more. And so hell yeah. So let's do this one more time. And then we're gonna go out and bid on the house. The house, you can't. Somebody already bid $400,000. So you have to bid more than that. And so you could either pay a cash bid, you know, cash, that's going to be positive money, or you could, you know, have negative money. Obviously, most people are just going to get a loan, so it's going to be negative money, but it has to be more. So if I'm going to bid on this house, it's going to be negative, you know, 500,000, or a bid of 500,000. Someone already put in a bid of 400,000, so you can't equal that bid. You know, the person who bid 400,000 already gets that house. You can do more. So that's where this is just a greater than sign. It's not a greater than or equal sign right there. Hell yeah. And then with food, it's going to be a greater than or equal sign. You can either pay $10 and just move on with life, or like most everything, you know, you're going to have to chisel out some extra cash and figure out if it's just 20% or like 40% these days. It's crazy. But anyway, hell yeah. So with food, you can either pay equal to $10 or you can pay more. And in this example, with the absolute value is like if I'm using a credit card, I'm going to do like negative $12. And that's going to be, my credit card is going to get billed $12. I'm giving them negative money. I can give them more negative money, which is X is less than or equal to $10 in this case, or X is greater than or equal to $10. So that's kind of the solution that we're going to see there. Okay, hell yeah. Let me get some water. We're going to redo this one, and then we're going to take a look at those two. All right, hell yeah. So we're back. And what's going to happen with this dentist problem is we're not even going to hit the middle anyway. You know, it was kind of, so that's not exactly how the dentist does it. It'd be cool next time I go to the dentist to kind of figure out what my bill would be, what I pay in cash, and then we can come up with an exact equation. But hell yeah, let's try this one out. So I'm going to get the absolute value there. I'm going to get that to the other side. So I have 1,000 minus 0.05x. This absolute value means that this could be a negative, you know what I mean? So whatever this value is, I could have that value over here be a negative. And so, hell yeah. Yeah, that's what tripped me out. Because, let's say this value over here is just 10. The value inside here could be negative 10, but because we have the absolute value, this will check off. Or this could be 10, and this could be, just 10. And let's see what happens. So if this is 10 is greater than 10, this has to be, greater than 10. It has to be like 11. Cool. If this is negative 10, that becomes 10. Well, this also has to be like 11. And so that has to be a negative 11 in there. And so negative 11 is a smaller number. And so X has to be less than negative 10, and X has to be greater than 10. Those are the two solutions that we would find. And so, now I'm just going to, do what they do, is that they would say this, if I had, let's just try to make this as simple as possible. If I have the absolute value of X is greater than 10, my two equations would be X is greater than 10, and then X is less than negative 10. And I don't know. Like you could also look at this as X is equal to 10 and X is equal to negative 10. You know what I mean? Because if I did have the absolute value of X is greater than or equal to 10, one of the solutions is the fact that just the absolute value of X is equal to 10. And that's where you get both of those solutions. So I think sometimes it is useful to actually, set up, even though you have this, to set up an equality just to see what you would get. Hell yeah. Because if the equality said you would get X is equal to 10 and then X is equal to negative 10, I'm just trying to find ways. Like, I didn't find a very good way to be like, okay, now to get, the fact that we changed this side to negative 10 meant that we maybe multiplied by a negative 1. And if we did that, the equality changed. But I don't think there's any like tried and true way other than just saying, hey, we're going to have two equations and the negative equation is going to flip the sign. Even just doing these equations like this, I'm not too excited about from a fundamental perspective. All right, hell yeah. So let's do it though. So we're going to have two equations. We're going to have X is greater than 1,000 minus 0.05x, and then we're going to have x is less than a negative 1, and then 1,000 minus 0.05x. Cool, and we're going to solve both of these. So this to the other side becomes 1.05x is greater than 1,000, and x is greater than 1,000 divided by 1.05. This is going to be our positive answer. And so at the dentist, and I dropped the equal sign. So yes, we will say this is greater than or equal through all of these. Because at the dentist, you can either pay more money or equal to. And so this is going to be our positive answer. And 1,000 divided by 1.05. So this says that our bill is going to be greater than or equal to $952.38 if we pay cash, positive money. So now we're going to do the other equation, which will signify negative money. And that's going to be this one right here. So we're going to have x is less than or equal to. And even like right now we have an idea of like why we have this less than sign. Because less than is going to be a number that's smaller, a smaller negative number. So if I have negative 1,000 compared to negative 2,000, this is the smaller of the two negative numbers. But it's still, for our problem, is going to indicate that we're using negative money and we're going to have more of it. So anyway, so kind of two different ways to look at that. All right, so this is going to factor through. We're going to have negative 1,000. This becomes positive 0.05x. When I get this to the other side, it's going to subtract. So we're going to have 0.95x is less than, and we're going to have that negative 1,000. And then I'm going to divide by 0.95 on both sides. So we have x is less than or equal to negative 1,000 up. And sorry, there's no x here. So I got this to the other side, this x to the other side, by subtracting it from both sides of the equation. You know, that's what the pros do. Hell yeah. And that's what you're doing. Cool. And then I just have this negative 1,000 here. I'm going to divide both sides of the equation by 0.95, and that's the next step. And so I have x is less than negative 1,000 divided by 0.95. So my bill, if I pay with a credit card, is going to be $1,052.63. Now, at the dentist... Alright, hell yeah. No, I just will say this is not how it works at the dentist. The dentist will have whole numbers for their bill. It'll be like, hey, this is going to cost you $1,000, and then we can give you a discount if you pay credit. I just decided that this was a good equation that kind of hits that middle ground. One is a larger number, larger negative number, you know what I mean? It's a smaller number, that's why this is smaller than or equal to. But the dentist, you know, they're like, hell yeah, give me more of that smaller number. Because it's credit. Okay, hell yeah, enough said on that. Okay, and yeah, so we did kind of all of those. And so hell yeah. So now I'm just going to do the organic chemistry tutor one, and we can do them from a graphical perspective because those videos don't do that. So we have, let's say this side is an equation. So y is equal to 2x plus 5. That's going to hit 1, 2, 3, 4, 5 right there, and it's going to have a slope of 2. So I'm going to go, and it's going to be a positive 2. So I'm going to do this. Booyah, down 2 over 1, down 2 over 1, over 1 up 2. Hell yeah. So here's my equation right there. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then so, hell yeah, there's 11. So here, if this equation is an absolute value, the negative is nonsensical. This can't be a negative. And so once it hits here, it's going to be just a mirror image. So we're just going to do this, you know what I mean? And then 1, 2, 3, 4, 5, 6, 7, 8. I don't know. So it looks like our answers... And then so if we did put an equal sign here, it's just where it intersects. You know what I mean? So you're just like, hell yeah. it looks like when x is 1, 2, 3, I don't know, 3 or 4, let's just say 3, we're good to go. And then when x is 1, 2, 3, 4, 5, 6, 7, 8, negative 8. Hey, so we even just kind of have a check on reality. Now, what does this inequality sign mean? Well, it says that this side has to be big. All right, hell yeah. So new battery, and so here's potentially our two solutions. And so what this, oh yeah, this inequality being greater than. So if this is the function on this side that represents this line right here, this line has to be greater than this line, this function. This is just a constant. And so if it intersects, hey, this number isn't greater than 11. You know what I mean? And so it has to be like right there. So these are the values that make this good to go. And so again, this could be, I think it's a great idea to think of this as positive money or negative credit. You know what I mean? Where, hey, if you pay credit, you're going to pay more. Pay positive money, you get to pay less. Alright, so let's set this up as two equations. We're going to have 2x plus 5 is greater than 11. And then we're going to have 2x plus 5 is less than negative 11. Okay, so we're going to subtract 5 from both sides. This becomes 7 over here. And then this goes away. And then we're going to have x is greater than 7 halves. And so that's pretty close to about 3. You know, that's 3.5. So x is greater than 3.5. Our guess was hella close. All right, let's do this one. So we're going to have 5. We're going to subtract 5 on both sides. So we have negative 16 2x. And we have x is now negative 16 divided by 2. Sorry, that's x is less than 8. So hell yeah. I'm sorry. X is less than negative 8. You know, that's why you do this graphically, to be like, hell yeah, there's my initial guess, there's my initial guess. Almost messed up a negative sign, but we did it. Okay, hell yeah, so that is the tip-top way to do that. And look at this. This was a linear equation that now, like, banked back up. So this linear equation now looks like a x squared equation, which we know x squared equations can have two solutions, and that's what we have to this problem. So look at this. Let's say we had an x squared equation that was like this, but now it can't be negative. So that x squared equation would come down, and then instead of doing this, would do this. And then if I have a constant going through there, now I have up to 4 solutions. And so that's kind of, that was my intuition and my grasp from today. But I do like this video, even though it's hella scattered, is because, you know what I mean, there's plenty of videos like that are just little chat GPT, you know what I mean, saying the correct stuff just in video format. Now that is useful, you know, if you're making horrible errors, you know, to make sure I'm on the right track, to figure out what this negative, multiplying by a negative, it's almost a rule where we have come up with ways to kind of show like why that rule is enforced, and yeah, the whys behind it. All right, so hell yeah. Let's keep crushing. So this, another one, we're going to have negative, so negative 4, 1, 2, 3, 4, and then, you know, over 1 up 3, 1, 2, 1, 2, 3, over 1 up 3. So, and then, oh, did I do that right? Hell yeah. So that is my line. It can't be negative, and so we're just going to be something like that. And then we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, about there. And hell yeah, just continue it. So booyah, what is this? 3, 4, 5, 6, 7, 8. So I think my answer is going to be close to 8. And then what's this? 1, 2, 3, 4, 5. Maybe 5, maybe 6. And then what does this say? It says this equation that we did has to be less than this number 17, this equation. Okay, so all of this is my answer, like all of that. And so, you know what I mean? And the other thing that the videos did is like, well, if I do find a solution, the solution, and it can be equal, is going to be x is, you know what I mean? X is going to be greater than or equal to 5, and then maybe less than or equal to 8. And the other way you could write this is that it's going to be 5 to 8. Where this one, we had the solutions where x was greater than 3, so x was going to be greater than 3, and x was less than negative 8, and it was, 3.5. So hell yeah, so this is what we had here. Now I could have negative infinity, like that works, and I can have x is greater than, and I can have positive infinity. You know what I mean? So to write this, I would have negative infinity to negative 8. It's not bracketed in. Bracketed in means I get to include negative 8. This has to be greater than 8. And did I even do that right? Hell no. Hell no, I didn't do that right. So x is less than negative 8, and then x is greater than 3.5. And so how would I write that? X is greater than negative 8, and x is, alright, sorry. Yeah, so x is greater than 3.5, and x is less than negative 8. Is that how you write it? That just kind of, that threw me off for a loop, but I think we got it. And so this can be negative infinity to negative 8, but not negative 8. So, and negative infinity isn't a number, so it's open there. You're not going to bracket negative infinity. It's not a number. You can't bracket negative 8 because it has to be less than that. X has to be less than that. And so, and then you have the union. You know what I mean? This is kind of my first... Oh yeah, this is the first time I've actually said this. So there's some mathematical terms that don't get used very often, and then people are just like, nah, let's not do those. But hell yeah, I'm okay with the mathematical terminology. Yeah. So it's just sometimes it's obscure, and it's just, is this even worth it? Okay, hell yeah. And then it's going to be 3.5, but not 3.5. It has to be greater than 3.5 or 7/2. All the way up to infinity. So that's what we have there. And infinity is not a number, so you can't bracket it in. Okay, hell yeah. So back to this one. So this is our answer, 5 to 8, but we'll do it for real. So we have 3x minus 4 is going to be less than, I get rid of the absolute value by doing two equations. So we have 17. And then we have 3x minus 4 is greater than or equal to negative 17. I'm going to add 4 to the other side. That's going to be 21. And I'm going to have 3x. So I can just say x is 21 divided by 3. X is less than or equal to 7. And hell yeah, that's about what we had. We thought it was 8, but it's 7. And then let's do this one. So I'm going to add 4 to the other side. That becomes negative 13. And then I have 3x here, so x is greater than or equal to negative 13 divided by 3. And we could do this, you know what I mean? What's negative 12 divided by 3? That's 4. That's negative 4, and then I'm going to have a third left over. So negative 4 and a third. And that's kind of what we have. We said it was 5. It's negative 4 and a third, which is negative 13 divided by 3. Negative 4 and a third. Hell yeah, we did it. And then I think there was just, like this one. This one, the absolute value has to be, this was the trick. I'm just going over these for my sake. I'm not trying to plagiarize the same problems. Probably, though. Yeah, so this value could be 0, or it could be a positive number, or like positive infinity. That's kind of the range it could be. You know what I mean? It could be, that's the range. Look at that. And are any of those less than negative 3? No. 0 is not less than negative 3. So this problem has no solution. What you would have graphically is that you would have, well, let's talk about it. A linear line, wherever it is, can never get down to this negative region. That's the fastest way to look at this. And that is equal to a constant that's down here, negative 3. Now we could do this right and be like, hell yeah, 1, 2, 3, 4, 5. And then we have a slope of 3. So over 1, 1, 2, 3. You know what I mean? And then it reflects. But again, it's not going to touch this negative line. So that was kind of the first one that doesn't work. You have no solution. And then this one, like everything was a solution. Because you can have 0 here, Like, obviously, you can have 0 here. It's an absolute value. You can't have a negative. You can have a positive, and I'm sure you could have a positive infinity. Are all of those solutions going to be greater than negative 4? Yes. So, I mean, just the fact that you have an absolute value here, it can't be less than negative 4. And so they're all greater than negative 4, no matter what I put in here. Well, and then, because even if I put in a 0 here, I was like, oh, we got a negative 3, but this becomes a 3. So it's always 0 to positive infinity. That's the range on that. 0 to positive infinity. And that is always going to be greater. Always going to be greater than negative 4. So, and then this is what they didn't do, so we're going to end on that. Just try to do it real fast. If I did separate this into two equations, I'd have 4x minus 3 is greater than negative 4, and then 4x minus 3 is less than 4, just switching this negative sign. And then so this would be negative 1, get that to the other side, add 3 to the other side, and I would have 4x. And x would be greater than negative 1/4. X is greater than negative 0.25. And then here, I'm going to add 3 to the other side, so 4x is less than 7, and then x is less than 7/4, which, and so what would this mean? If we chose those, I would have on a number line, negative 0.25, x is greater than that. Okay, so x is greater than that. And then I would have x, so this does work. You know what I mean? So, yeah, so no, this solution works as long as you just do it in the number line format. That was the fascinating thing. And so we should go back to this one and see what it does, and, if it gives you just answers that don't work. Because this is greater, any number greater than negative 1/2 this way is going to work. And then if I go to 7/4, like that's almost 2, 1, 2, then it's any number less than that. Any number less than 7/4 also works. So it's still hitting negative infinity to infinity. That's the range on that. Hell yeah. It was just kind of fascinating with, like, what if you did do it with that approach, what would happen? So I guess we are going to go back to this one and see what we would do. So we have 3x plus 5 is less than negative 3. We're going to do two equations. We're going to say 3x plus 5 is less than negative 3, and then 3x plus 5 is greater than positive 3. I'm going to get this to the other side, and so we have, that's going to be negative 8. 3x. So we have x is less than negative 8/3. This one, I'm going to subtract 5. Yeah, it's the same on both sides. Subtract 5, but we're subtracting 5 from 3. That's going to be negative 2. 3x is greater than negative 2. X is greater than negative 2/3. And then, so then on a number line, I would have 0, and then I would have like negative 2/3, negative 8/3, that's going to be over here, negative 8/3, and I would have x is less than this, that would be that way. It would be open if it's less than, and then x is greater than. Yeah, so this just gives you the wrong answer, you know what I mean? So that has to be a check on reality, that when you actually go put in a solution, that, you know what I mean, because this is about negative 3. So if I put in negative 3 here, I'm going to get 3 times negative 3. That's negative 9 plus 5 is negative 4. Absolute value, that's 4. 4 is less than negative 3. See, I'm going to always strike out. This is either going to be 0 or a positive number, and that can never be less than negative 3. Cool. All right, so that's a good place to end it. We did it as, I don't know why I'm even talking more. But I did like my setup for this. We used bidding on a house where you can't equal that bid. You have to do more. You have to do more. And then you have like food and paying someone at the dentist. You can either pay equal or you can pay more. And then we talked about how the absolute value can come in on all of these, because you could say the negative money is credit, the positive money is cash. And you need, more cash, a bigger positive number, but you need a smaller negative number. That means, visually, minus the negative sign, negative $2,000 is still less than, on this. It's just the fact that we came up with a number line and we say numbers to the right are always larger than numbers to the left. But I can use this smaller number to indicate, kind of a pinch on your credit card. You know what I mean? And the dentist is smiling. Hell yeah. Okay, so we did it. Thanks for joining me. Booyah.